everyone. So today we will discuss about the types of decimal number present in the number system. Decimal number means there is the presence of a decimal number or decimal point. Okay. So especially there are three types of decimal number. What are they? The first one is terminating decimal. Okay. It is terminating decimal. Second one is non-terminating and repeating. Okay, and the third one is non-terminating and non-repeating. Okay, so there are three types of decimal number: terminating decimal, non-terminating repeating decimal, non-terminating and non-repeating decimal. So let's talk about terminating decimal. Okay, suppose I am taking an example 3 or 31 divided by 10. Then we can find the division. 31 is divided by 10. Then 10 3 is 31. Then you use the decimal point. So 0, 10 1 is 10. And here you get the remainder to be 0. Since the remainder here is 0, that means here the division process stops. So we get 31 by 10 is equal to 3.1. And you can see after one decimal point, this is the first decimal point, the division stops. Okay. Since it stops, that is why it is known as terminating. So the meaning of terminating is if any decimal expansion, okay, stops after certain decimal place. Okay, if any decimal expansion stops after certain decimal place, then it is known as terminating. Terminating means it stops. Okay, it doesn't continue. Here it stops after 1, that is why it is known as terminating decimal expansion. Now it is clear. Okay, so let us talk about the non-terminating and repeating decimal expansion. Here are two terms. The first term is non-terminating. As we know, that meaning of terminating is if a decimal expansion stops, and non-terminating means if it doesn't stop. Okay, if the decimal expansion doesn't stop, okay, then it is known as non-terminating. And what is the meaning of repeating? Repeating means if any digit, okay, will repeat. So if in a decimal expansion, if any digit after the decimal point repeat itself, and second thing, the decimal expansion does not stop, then this type of decimal expansion are known as non-terminating repeating decimal expansion. We will take an example of that. Suppose 22 divided by 6. Then let's divide them. 22 divided by 6. 6 3 is 18. So 4.0. 6 6 is 36. 4 0. 6 6 is 36. 4 0 6 6 is 36. And 4 0 6 6 is 36. So here you see the decimal expansion goes continuing towards the right, and the division also continues, and the remainder is not equal to 0. That means the division does not stop here. That results in not terminating the decimal expansion. So here the 6 digit repeats again and again, and the decimal expansion will goes towards the right. So we can write 22 by 6 is equal to 3.6666 ... That means here you can see the decimal expansion does not stop. That is why it is known as non-terminating. And a digit 6 is repeating again. So it is known as a repeating decimal expansion. And this type of non-terminating repeating decimal expansion can also be written as 3.6 bar. 6 bar means this number repeats again and again. Okay. So this is the second type of decimal expansion. Suppose there is a question 4.73 bar. It means what? It means which number repeats? 3 number is repeating. So it can be written as 4.73 3 3 3 3. Okay, suppose it is 1.234, and it is written as 1 point, here 3 4 number is repeating again and again, so you can write 1.2343434 dot 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 dot. And this type of decimal expansion is non-terminating and repeating as well. Let us take one more example of non-terminating and repeating decimal expansion. Suppose I am taking an example 31 by 3. Okay, I have to find out the decimal expansion of this fraction. How? Divide 31 by 3. So 3 1 ja 3, 1 goes to the down. Okay, so 3 0 ja 0, 1, you have to take a point here, it will be 10, 3 3 ja 9, then 1 0, 3 3 ja 9, 1 0, 3 3 ja 9, and 1 0. This procedure will still continue because we can never get 0 at the remainder. Okay, and here also this 3 will goes on towards the right, hence we get 31 by 3 is equal to how much? 10.333 dot 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 dot. That means it is a non-terminating decimal expansion, and here the term or the digit 3 will repeat itself, hence it is written as 10.3 bar. Clear? One more example you can take. Suppose I am taking 22 by 7. Okay, so let us divide 22 by 7. So first 7 3 ja 21, 1.0, 7 1 ja 7, 3 0, 7 4 ja 28 2 0, 7 2 ja 14, 6 0, 7 8 ja 56, 4 0, 7 5 35, 5 0, 7 7 4 9, then 1 0 again, 7 1 7, 3 0, 7 4 ja 28 2 0. Okay, 7 2 14, 6 0, 7 8 ja 56, 4 0, 7 5 35, 5 0, and 7 7 49. Okay, and this process will continue because we can never get 0 at the remainder. Okay, so it is a non-terminating decimal expansion. Why? Because in this case you can see after the decimal place this number are goes on towards the right and they doesn't stop. Okay, and you can see one thing here, 142857, again 142857, again we can get 142857. That means this 6 number 142857 repeat itself, not only 1, not only 4, all the 6 number are repeating themselves again and again. That is why 22 by 7 can be written as 3.142857 dot 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 dot. That means you can write which digits are repeating. This 6 digits are repeating, so you can write 3.142857 over bar. Okay, so this is the correct representation of a fraction into the decimal expansion. Clear? Now let us talk about the third type of decimal expansion, that is non-terminating and non-repeating. Okay, so in this type of decimal expansion you get two terms here. The first is non-terminating. It means the decimal expansion does not stop after certain place, and non-repeating means here no digits is repeating after a regular interval. Okay, suppose I am taking an example. Suppose I am writing 1.315796845693134 dot 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 dot. Now you can see in this type of decimal expansion after the decimal place, though the number 6 is repeating, though the number 3 is repeating, okay, but they are not repeating at a regular interval. Okay, since these 3 and these 3, in between these 3 there are enough numbers, but here these 3 and these 3, in between them there is only one number. That means the numbers are not repeating here. So it is non-terminating. Again, here you can get the decimal expansion and dot 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 terms. It means this decimal expansion does not stop. So it is non-terminating and non-repeating decimal expansion. Okay. So out of the 3 decimal expansion, as you have studied, first one is the terminating decimal expansion, terminating decimal expansion. The second one is non-terminating decimal, non-terminating and repeating, yes, repeating decimal expansion. And the third one is the non-terminating and non-repeating decimal expansion. Okay, out of these 3 decimal expansion, the first 2, that is the terminating decimal expansion and non-terminating decimal and repeating decimal expansion. These 2 type of decimal expansions are also known as rational numbers. These 2 are rational numbers, but the last one is an irrational number. Okay, so the non-terminating and non-repeating decimal expansion are irrational number. So this is an irrational number, but the previous 2 are rational number. Okay, now you can find the decimal expansion of any fraction